Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to do the lecture of topic of today's lecture is 4.6, and pages we will cover today, page number 93, then 94, 95 and 96. These 4 pages we will cover today of your 9th class textbook. First of all, I start my lecture from center of mass, which is on page number 93 of your textbook. You can open your textbook side by side, so that you know where we are. First of all, I read the definition for you. This is in pink box on page number 94. First of all, I read the definition for you. Center of a mass of a system is such a point where an applied force causes the system to move without rotation. This is the definition which is given on page number 94 of your 9th class textbook. First of all, we will see these figures first. So this is a small mass. I say this is point A. Then this is a big mass as compared to A mass. So we have, say this is the B point. I'm going to explain this definition for you first of all. Center of a mass or system is such a point when an applied force causes the system to move without rotation. Okay, I say this is A point, then this is B point. And what happens if I apply the force with my hand? So at point A, what will happen? After some time, this ball will move, or this if I apply the force here, the body will rotate. After some time, the body will rotate. I mean to say clockwise direction, right? But what will happen if I apply the force, if I apply the F force with my hand on this point? The body will also rotate anti-clockwise, like this will anti-clockwise rotate. So there are the 2 points, A point and then B point. These are the 2 points where the body will rotate. After some time, it will go first straight and then it will go anti-clockwise if I apply the force at point B. And if I apply the force at point A, the body will move clockwise. You can imagine if you have a duster in your hand, what will happen? It has suppose the corner points are A and B. What will happen? You can do this experiment at home. No worries. Take up the duster and mark the corner points are A and B. If you apply the force at point A, the duster will rotate clockwise, and if you apply the force at point B, the duster will move. At anti-clockwise. So this is the only point C where if I apply the force, the body will not rotate. This C point, the body will not rotate. It will move straight. This is the new position. These are the new position. If I apply the force at point C, what will happen? The body will not rotate either clockwise or anti-clockwise, but it will move. It will take the new position. First, I apply the force here. The new position is here. Then I apply the force. The body will move straight. So this point C will be my comb point. Comb point means center of mass, which is the definition of. In this position at point C, the body will not rotate. In this position, the body will rotate. In this position, the body will rotate if I apply the force here and here. But if I apply the force at point C, the body will not rotate, but it will go straight. This is the first position. Then if I apply the force more, then the body will move the second position. So where the body will not rotate, that point is called center of mass. This is given in our center of mass definition. Center of mass of a system is such a point where an applied force causes the system to move without rotation. So where the rotation is occurring, here this point rotation is occurring. This point body is moving clockwise, anti-clockwise. This point body is moving clockwise. This point body is moving anti-clockwise. But this is the only point where the body will not rotate either clockwise or anti-clockwise, but it will move in a straight line. It will move other position. First, this, if I apply the force here, then this will be the first position. If I apply more force, then this will be the second position of this body. So it is only the translation. It is only the translation. This is the first translation, and then this is the second translation, or you could say the new position. So where the body will not rotate, this is the only point where the body is not rotating, it is moving. So this will be my COM point, or this is called center of mass. Now, so this is the end of the definition of center of mass. If you read the text, if I read the text for you for center of mass on page number 93, to make you more understand it clearly, it is observed that the center of a mass of a system moves as if its entire mass is confined at that point. So entire mass of the body is confined at this point. A force applied at such a point in the body does not produce any torque. Torque means here torque is producing because turning effect of the force is called torque. Here it is also the torque is producing because turning effect of the force is called torque. But this is the only point where the body is not moving clockwise, not moving anti-clockwise. Rotation is not. These are the points where the body is rotating. But this is the point where the body is not rotating. This will be our fault COM. So students, if you read this, so in book they have say this point O. So you can change this from here. I'll just put it. These are the assumption points. This is the O position, O point. O point is called the center of mass. Now I move towards the subtopic of center of mass, which is called center of gravity. Center of gravity is basically similar to the center of mass. Suppose I read the definition for you. This is also on page number 94 of your 9th class textbook. What is happening here? A point where the whole weight of the body appears to act vertically downward is called center of a body. So if I say center of mass is actually is a point where the force of gravity is acting. This is the only point where the force of gravity is acting. So in my first example, so this is the center of mass. This is the point. This is the only point where our earth force is attracting. This is the only point where the earth force is attracting. So center of mass is actually the point where force of gravity or force of the earth, which the earth is applying the force on the body, is acting. So this is the only point where the force of earth is attracting. So what is going to, I'm explaining this. Now I'm going to read center of gravity. Center of gravity, a point. This is also a point where the whole weight of the body, you know, the weight of the body is acting downward. Weight is the force with which the earth attracts the body towards its center. So this is the difference between, this is the weight. Weight of the body appears to act vertically downward. Now, suppose the body is composed of so many points. This is the irregular body. Or you could say it consists of 1, 2, 3, 4, so many points. I consider only few points, 1, 2, 3, 4, 5, 6, 7. But this body, if you look at your textbook, you will see there are so many points where the arrow is pointing. Right? These are the so many points. So it means this body is constituted of of so many points. So suppose this is the point, this is the point, right? This one is the point. The a weight of the body is acting downward. So weight of this point is acting downward. Now this is another point where the weight is acting downward. So these all points are, so this point, this point, this this point, and this point, and this point. There are so many points. So these points are the weight of each. The forces are acting downward. These forces are actually parallel. So weight is also a force. So don't confuse between force and weight, because weight is also a force. So the weight of this particle is acting downward, the weight of this particle is acting downward, then similarly the weight of this particle is acting downward. So um, weight of this particle is acting downward, so this is the weight of this particle acting. So these are also parallel to each other. Look, if I use the if I use by head to tail rule, as you have already studied head to tail rule, when we have so many forces, so if they are vector quantity, then we can add them up with the help of head to tail rule. So if we, this is F1 force, this is F2 force, then this is F3 force, F4, F5, F6, F7, and so many more. I just took few of them, but if you look at your textbook, there are so many points, right? So if I take the resultant of this, so this will be the resultant. This point will be the resultant. This is also called the center of mass. And center of mass, I have already told you, center of mass is a point where the force of gravity is acting on that body. It means this is the only point where the force of gravity is acting. So center of gravity, a point where the whole weight. So this is the point where whole weight of the body appears to act vertically. Vertically downward means it is acting downward, this direction, vertically downward. So vertical is same straight and acting downward. So it is called center of gravity of the body. So what I did, I actually take so many points, and then I, with the help of head to tail rule, I found the resultant force. Resultant force is noted with letter F, right? So I add them up by head to tail rule. Then this point comes, and this point is called center of mass. Center of mass is the point where the force of gravity is acting on this point. So this will be my center of gravity, or center of gravity, or center of mass. Or center of mass is the point where the center force of gravity is acting. So this is the only point where my force of gravity is acting, and this is actually in the center. So this is end of center of center of mass, I have told you, and this is center of gravity. So now I find the center of gravity. I find the center of gravity of different shapes. So first of all, I consider center of gravity of symmetrical shapes. So center of gravity of symmetrical shapes. How can I find the center of gravity of symmetrical shapes? Look, this is a sphere and this is a rectangle. So sphere is a figure where all the sides are equal, right? This side is equal to this side. If this is 4 centimeter, this is 4 centimeter. This will be also 4 centimeter. This will be 4 centimeter as well. So first of all, we find the center of gravity of the symmetrical object. These are the objects. These are all the objects. So I consider a circle, then I consider the rectangle. So if I find the center of gravity of, if I consider the center of gravity of sphere, what will happen? This is the this point. This center point where these two lines are, these are called actually the diagonals. These are actually the diagonals. So this is my diagonal. Here, this is the diagonal. This is first diagonal of the, and this is second diagonal. Where the two diagonals are center of gravity, if I want to find out the center of gravity of sphere, so what will happen? Center of gravity will be lying where the two lines are, where the two diagonals are cutting each other. It means this will be the center of gravity. This center will be the center of gravity, and center of gravity is simply CG means center of gravity, or it is simply in your textbook, it is simply denoted with the letter G, capital G. So you will find in your textbook the G letter will be here. So it means where the two lines, where the two diagonals cut each other, the middle point, this point where my arrow is, so this point will be as G, or center of gravity, or it is simply say G, is not even letter G. Now if I consider the other symmetrical object, which is called circle, you know, this is from this point to this point, this is the diameter of the circle. This is the diameter of the circle. Similarly, this one from this point to this point, this is also the diameter of the circle. So these two diameters are cutting each other at this point, so my center of gravity will be at this center. So my center of gravity is this point, G point, where my arrow is, this point. If I consider the rectangle, so same as circle, but the difference between rectangle and circle is the two opposite sides are equal. So this side is opposite to this side, or this side is opposite to this side. If it is 6 centimeters, this will be 6 centimeters. If it is 4 centimeters, this will be also 4 centimeters. The opposite sides are equal. This is called a rectangle. But on the other hand, if you consider this one, so in circle, in square, we have all sides are equal. But if rectangle, this side is equal to this side, and this side is equal to this side. Opposite sides are equal. If it is 4 centimeters, this will be 4 centimeters. So in order to find the center of gravity for rectangle, so again, this is the where the two diagonals cut each other. This is the first diagonal, and this is the second diagonal. So these two diagonals are cut together. So where they cut, this center point is called the center of gravity, or simply G. So this we discussed center of gravity of the symmetrical shapes. Now we discuss the now we find the center of gravity of irregular shapes. What is the difference between regular shapes and irregular shapes? Regular shapes, these are the regular shapes, these are the symmetrical shapes, but this is irregular shape. Why? This is 1 point, this is second point, this is third point, this point is third point, second point, third point, 4 point, 5 point. It looks like a pentagon. So this point A, I say this point A, this point as B, and this point as C. This is my D point. Now I am finding the center of gravity of irregular shape. To find the center of gravity of irregular shape, we use plumb line. Plumb line is used and put at different point. You know, this is what is a plumb line? Plumb line is basically consists of a I give you the example. Suppose we have shapes, right? So this is suppose this is a string. Suppose this is a string, right? String means this is a string, and there is a very small mass each attached at this end. Suppose I take a small mass. This one is a small mass. Suppose this is a small mass. It is actually in this shape, right? So very small mass is attached on it. So we find the center of gravity with the help of this. This one point is called plumb line. From this point to this point where my arrow is pointing, this point, this is called my plumb line. This is actually the physical shape you can see in your laboratory or you can either type on Google. You will see the physical shape of the plumb line. Why we use this plumb line? In order to find the center of gravity of irregular shape. Suppose this is the irregular shape. Why I am saying these are the regular shapes, but this is my irregular shape. Why I am saying this is irregular shape? Because there are so many points, 1, 2, and this shape is not regularly symmetry. It is irregular shape. So in order to find the center of gravity of irregular shape, what we do, we take a nail and pass our this point. First of all, we pass the nail over this point, and then we use the plumb line which is acting, which consists of, this is a string and this is my small mass attached to this string. This is called plumb line. So what will happen? I pass the nail over here. I pass the nail over here at point A, and what will happen, and pass the plumb line over here. So this will be my first line, and then I pass the nail at point B. So what will happen? Then I use the plumb. Now my B point will be then A point. Where my A point is lying, then I pass the nail at point B. This line will pass through. If I use the plumb line at point B, I use the plumb line at point B, this point will cross. Where these, similarly, I pass the nail at C point and then D point, then this point is E point. This point C, A, B, C, D, so this is E point. This is E point, this is D. I pass, first of all, I pass the nail from this point and attach the plumb line. Then I mark the line over there. This will be the straight line. Then I pass the nail at point B. So this will be, and I attach the plumb line over here. And this will be the point B now. So this point will be passed through it. So if I take the intersection, one line, two line, I just showed you the two lines, but actually there will be the first of all, I pass the nail at A point, then B point, then C point, so then D point, and then E point. So turn by turn, I pass my nail 4 points, and four of these lines will come. Four of these lines will come. 1, 2, then I pass the nail from C to 3, and E 4, or D 5. So 4, where these 4 lines intersect. Suppose I make the figure for you. Look, this will be one line, then shape another. This will be my second line, and so this will be my third line. How many points? 1, 2, 3, 4, 5. This is E. I didn't mark it here, but if you mark it at E. So 1, 2, 3, 4, 5 points. So how many lines do I have? 1, 2, 3, and 4. 1, 2, 3 lines. So I draw 2 more lines. Suppose this is the another line. Like, okay, then I take another line. Suppose it is passing from here. Okay, so this point where all the lines are cutting each other, this line. So this will be my I find the center of gravity of irregular shape. So guys, this is the end of my lecture, center of gravity of irregular shape. Now I revise this lecture to you again. I revise this lecture to you again. Then we start today's students. What we did, we covered the topic 4.6 pages. We covered today 93. 94, 95, and 96. First of all, I gave you the concept of center of mass. We discussed the definition of center of mass. We discussed about where is what is formed, which is called center of mass. Center of a mass of a system is such a point. This is a point. This is a point. This one, not this one, not this one, this one, this middle one. Center of mass of a point is such a point where an applied force causes the system to move without rotation. Look, if I apply the force here at point, I have two small masses. One mass here, then I have bigger mass here. So I have two masses, small mass and big mass. If I apply the force at A with my hand, I apply the force with my hand at point A, what will happen? The body will rotate clockwise. But if I apply the force at point B, excuse me, at point B, the body will rotate anti-clockwise. So if I apply the force, if I don't take this point A, if I apply the force here, what will body will again rotate clockwise. If I apply the point at this point near the point B, then the body will rotate anti-clockwise. These are the points or somewhere between these three. So body will rotate either clockwise or anti-clockwise. But what is center of mass? Center of mass actually is a point where if I apply the force at point O, what will happen? The body will not rotate clockwise. The body will not rotate anti-clockwise. But this is the point where the body will move straight. So this point is called center of mass. Now, this is end of center of mass. Now, center of gravity. What is the center of gravity? I consider a shape, any shape, irregular shape. This is not a symmetrical shape, not a regular shape, but it is any shape. So, how we can find the center of gravity? And because I'm talking about center of gravity now. So, with this shape, a point where the whole, I read the definition. This is also in your textbook and pink box. A point where the whole weight of the body appears to act vertically downward is called center of gravity of the body. This body is consists of so many particles. 1, 2, 3, 4, infinite number of particles are there. But I consider only few points. This particle, this point, then this point, this point, this point, this point, this point. I consider only few points. But if you look at your book, you will find there are so many points. In order to make you clear, I consider only few points. Suppose these are the force F1, which is acting downward, which is because you know the force. The weight is the force with which which is acting downward. So F3, F4, F5, F6, and F7. So these are the forces. So resultant, if I find the resultant force with the help of head to tail rule, what will happen? It will be a single force which has the combined effect of all the forces to be added. All the forces to be added. So then this will be the point where my all point will be where my all if I take the resultant of all these forces. So the resultant force is a single force which has the same effect with all the forces combined, acting combined. So this point is vertically acting parallel. So these points are parallel to each other, or these forces are parallel to each other. So if I take the resultant, so this will be the resultant force, or I denote this letter this with F. So what will happen? So this will be my comb point, or comb is the point where the center, where the force of gravity is acting. So this is my comb point, center of mass, and this is the point where the weight of all the body is acting vertically downward. So this is my center of gravity. Then I find how we can find the center of center of gravity of different shapes. First of all, I consider symmetrical objects. These are the symmetrical objects. This one is square, this is rectangle, and this is my circle. How can we find the center of gravity of the square? If I take the diagonal, this diagonal and this diagonal, where these two diagonals cut, this point will be called center of gravity of square. If I consider the circle, so where my diameters are cutting, so this is the point where my diameters are cutting. So this will be my G, or simply G, or I say center of gravity. If I consider the rectangle, what will happen if I these are the diagonals. So these are the diagonals. So if they are cutting each other, they are cutting each other. So this point, this center point is called center of gravity, or simply G. Then what happen? I consider irregular shape. How can we find the center of gravity of irregular shape? This is irregular shape. This one, this is irregular shape. This is my regular shapes or symmetrical objects. This is my irregular shape. How can we find the center of gravity of irregular shape? I told you, I mark these points. This point is A point, then this point is B point, this point is C point, then this point is E point, and this point is D point. So what will happen? So if I pass my nail from here, first point A, then I hang the plumb line actually over here. The center of gravity, I will mark this point. The line will come straight through here. Then I put my nail here. Then what will happen? And I hang my plumb line over here. This will be the line comes. Similarly, C point, this line comes. And I marked 6 lines because there are 6 points. 1, 2, 3, 4, 5 points. So 5 lines. 1, 2, 3, 4, and 5 lines. So where these lines are cutting, this point will be my center of gravity. Or the center of gravity or center of mass is the point where my gravity force is acting. So this is acting downward. So if you look at your figure, they have marked with the red arrow lines. So this is my center of gravity. I hope students you understand this. If you have any question, or if the part which you didn't understand, please feel free to ask the questions, so that, or also give me the feedback. How did you understand this topic? And if you don't understand any part of the lecture, I can repeat it for you, and please feel free to ask the questions. Thank you very much. And before I take the question and answer session, I will give you the homework for today's lecture. The homework is this: you need to memorize the pink definition. Like I gave you the definition of center of mass. You need to write this down, memorize this. Similarly, you need to practice the shapes as well. So and also write it down, memorize, read it as much as you can, or write it as much as you can, in order to make yourself perfect in this topic. So I hope you guys understand. If you have any question, feel free to ask. Yeah.